Let's discuss it. Okay, first, Atif, you tell me, what is the formula for the calculation of dipole moment?
Q into 2A.
Q into 2A. So, P is equal to, this is given by Q multiplied by 2A. Yes, Hania, you tell me, what is Q over here in this example? What is Q?
-2 plus 2.
-2 plus 2 is given. So, what are you going to take?
2.
2. Exactly. See, both the charges will be given to you and both the charges will be having the same magnitude. It's just that both the charges will be having the opposite signs, like -2 millicoulombs and +2 millicoulombs. So we cannot take minus or plus. We have to take out the magnitude of them. So that will be simply 2. So Hania, should I write 2? Is this fine? Or Q? Yes, Hania?
2.
Yes, anybody else? Is this 2 fine?
No, ma'am, it's millicoulomb, so convert it to SI unit.
Yes, exactly. Sure. See, it is 2 millicoulomb, Hania. So you have to convert 2 millicoulombs into coulomb also. So how do you replace this milli? What should I multiply it? Yes, Hania, try. Try once. Milliliters, millimeter. How do we convert all these units? 1000 we divide it by 1000. All right, we don't multiply it with 1000. So we'll multiply it with 10 to the power -3. You will divide it by 1000. That becomes coulomb. So Q is 2 millicoulomb, which is 2 into 10 to the power -3 coulomb. So this is your charge, magnitude of charge we have taken. Yes, Josefa, you tell me, what is the separation between these two charges? Till the time Josefa is also answering, all of you write me in the chat box what according to you is 2A over here in this question. Because coordinates are provided to you, you are not given direct reference. No, Shravya, check once again. Is this 2A? Means the separation between these two charges. Yes, rest of you also reply. Josefa, where are you? I haven't received your answer. Others also, Memuna, Sara, Shravya. Okay, Shravya has answered. Atif, Hania, you also try. Separation between these two charges. This is Q1. Coordinates are given 0, 0, -2. Means -2 millimeter for this side. 0, 0, 2 millimeters. Means 2 millimeters for this side. Yes, Josefa is right. Now, Shravya, you are right. This is the correct answer. Rest of you, respond please. Only Shravya and Josefa have given the correct answers. Atif, just look what is the distance before the graph, before the origin of the graph. You just have to look up the z-axis. Yes, Atif, correct. Yes, Shravya, your final answer is also right. So Shravya has calculated the final dipole moment also. See, this is the origin. It has given 0, 0, -2. Means this is for x-axis, this is for y-axis, and this is for z-axis. Means from origin till the charge where the charge is present, this distance is -2 millimeters it is given. Minus sign represents the negative z-axis. What is the magnitude? This means this is 2 millimeters. This separation from the origin till the -2 millicoulomb charge is 2 millimeters. Similarly, just look below the graph. Means below the origin over here, 0, 0, 2. How do you write it in the graph? If you are given this coordinate, how will you plot it? You will simply say this is X, this is Y, this is Z. At Z with 2 as marked, we have to mark that point. That will give us 2 millicoulombs plus 2 millicoulombs. So similarly, this is plus 2 millimeters. Now we have to take out the separation between these two charges, minus 2 millicoulombs and plus 2 millicoulombs. So 2 millimeters above the origin, 2 millimeters below the origin. That makes it 4 millimeter. Yes, ma'am. It will be 4 millimeters only. So separation that we have to take, this will be 4 millimeters. Again, we cannot write 4 millimeters. So 2A. 2A is the separation between the two charges that we have to take. So if the separation between the two charges is coming as 4 millimeter, we'll directly write this as 4 millimeter. 2A doesn't mean that you will double 4 millimeters and write it as 8 millimeters. You just have to see the separation between the two charges, whatever it be. Let it be whatever is this, just equate it to 2A. Means your separation between the charges is 4 millimeters, that is 4 into 10 to the power minus 3. This is 4 into 10 to the power minus 3. This gives 8 into 10 to the power minus 6 coulomb meter. This is the magnitude only. But is dipole moment a scalar quantity? Is this a scalar quantity? Is this answer sufficient?
No, it is vector quantity.
It's a vector quantity. Since it's a vector quantity, it is one thing is required along with magnitude. What is that?
Direction.
Direction. And the direction of dipole is from negative charge to the positive charge. So look up. This is your negative charge. This is your negative charge. From the negative charge to the positive charge. Just keep on moving. From the negative charge to the positive charge. So which axis is this? It's leading us to which axis? Z axis. So yes, positive Z axis. This is correct. Positive Z axis. See, you cannot only say Z axis because minus Z is also there and plus Z is also there. And both these charges are lying either on these. But when you are giving the directions, you majorly in your subjective answers, you have to include it in terms of I cap, J cap. So for positive Z axis, what do we have?
K cap.
K cap.
K cap. Yes. This is K cap. So your complete answer for this becomes 8 into 10 to the power minus 6 K cap coulomb meter. Understood how to use these basic dipoles? I have given you an assignment also. In that, question number 4 is not included right now in this chapter. There were 4 questions. Fourth question is not included in this chapter. It's from potential and capacitance chapter. But you all have not submitted this recent assignment. And from the previous only, Atif has submitted. All of you are not submitting your assignments. Just submit that, then we'll discuss if you're having doubts. So it's after time over here. I have to go. Just note down this part, then we'll continue. Yes, hello. Is this audible?
Yes, ma'am.
Okay, Shravya, fine. Then whenever your problem gets fixed, you can submit your assignment. Rest of you, please submit. Atif, only one assignment I think I've received of yours. Only this one, Atif. Submit the rest of the assignments also. And only 3 students have submitted. Khalid, Krishna, and Atif. So fine. Is this clear? Any doubts still here? Did you send it through WhatsApp or something, Shravya? I'll take it from him then. If you have submitted to him, then I'll take it. Okay, fine. Then I'll take it through him only using WhatsApp. Okay, fine. Now see, electric field on axial line of electric dipole. K cap, see, K cap, these are the unit vectors that we have. Majorly, you have 3 unit vectors. For x-axis, you use I cap. Now see, in I cap, when you have a positive x-axis, whenever you are describing the direction in the positive x-axis, then you can write it in this manner as plus I cap. And whenever you are writing it for negative x-axis, you can write it as minus I cap. So if you have written minus I cap plus I cap, that will define the direction by itself. You don't need to specify towards right-hand side, towards x-axis, towards negative x-axis. Whenever you're writing plus I cap, this will signify positive x-axis and minus I cap will signify negative x-axis. Similarly, for y-axis, we use J cap. J with this arrow, this represents J cap. So for positive y-axis, you have plus J cap, and for negative y-axis, this is minus J cap. Similarly, for z-axis, we have K cap. So positive K cap will be for positive z-axis and negative K cap will be for negative z-axis. Now see, in this question that we had, the direction of dipole is from negative charge to the positive charge. Means this was our negative z-axis, this is the positive z-axis. From the negative charge to the positive charge, that is directed towards the z-axis. So for positive z-axis, which unit vector do we have? We have plus k cap. So that's why we have written this k cap. Is it clear now?
Yes, ma'am. Thank you.
Now see, electric field on axial line of electric dipole. See what is meant by axial line. Whenever you have to derive an expression for the electric field and any of the axial line, first understand what is meant by this axial line. If I say I have this charge minus q with me, I have this charge as plus q with me, and let's say the separation between these two charges, this is 2a. 2a is the separation. So this is forming a dipole. Plus q and minus q. This is forming a dipole. So we have considered an electric dipole, which is consisting of charges plus q and minus q, separated by distance 2a. This is placed in vacuum. Let's say on the axis means this. This is the axis. So whenever you consider a point on this axis, let's say I've taken a point. Let's say this point is P. So this P point, this is located on the axis of this line. That's why we say electric field on the axial line of electric dipole. So this is the electric dipole. We have taken a point on the axis of this. So that's, and we'll be calculating whatever will be the electric field whenever we have a point on the axis of this dipole. That is what is meant by electric field on axial line of electric dipole. So let P be a point on the axial line, and let's take this distance from the center of the dipole to this point. Let's take it as R. So 2a is the separation. A will be half of it, But from the center of the dipole to the point, we have taken this separation as small r. All right. So this is the condition. Now see, we have to calculate the electric field. So individual electric field, we know how to calculate. Electric field because of negative charge, this minus q charge. Electric field due to this negative charge, we have already seen what is the general formula of electric field, kq divided by r square. This is the general formula for electric field. So k, what is k? How do we write k?
1
Yes,
by 4 pi epsilon naught.
Correct. Both of you are correct. This is 1 by 4 pi epsilon naught. So k we have written. Charge I am calculating due to minus q. So I'll be using this charge only. This charge is minus q. So let me write minus q over here just to distinguish between plus q and minus q. Let me write it in vector form only. Then we'll substitute the magnitude. Separation q and this point. What is the separation? Can any one of you tell me the separation between this minus q and this p point? This distance is small r. This is 2a.
A plus R.
A plus R, correct, yes. This much is R. And see, all of you see, if this is 2A, then it means this half of this will be A and half of this will be small a. That's why we are saying, no, both the separation between these two charges is 2A. So you just have to see this point where minus q is located and point P. So till here we have small r. What is additional over here? A only. So it means this is r plus A and the whole square of it. This is electric field. And then we have to see the direction as well. Direction of electric field. So minus q charge is there. So the force will be towards this charge. So electric field due to minus q will be E minus q. So let's say it is towards the left. This is towards left. Now similarly, we have to calculate it for the positive charge. Just the difference that will come out, it will be when we are writing this separation. Here it will be 1 over 4 pi epsilon naught multiplied by the positive charge that we have divided by. Now tell me, what is the separation between this plus q and this point? This was r. This is a. So this will be
R minus A.
r minus a. Yes, this is right. This whole is small r. This much is small a only. So what is left with us? This part is r minus a only. R minus a gives this part. Yes, Shabya, it will be r minus a only. So r minus a, this will be whole square of it. And this will be directed towards the opposite side, means in this direction. So this will be towards the right. How am I writing this towards left, towards right? I hope this is clear. See, for negative charge, you go towards that charge whenever you have to calculate electric field. So since this was the negative charge, we will go towards it. So direction of electric field for minus q, this becomes towards the left hand side. Similarly, for positive charge, we go away from the charge. So direction of electric field for the positive charge becomes in the opposite direction. Now see, these are the two vectors that you have at point P. If I rewrite it, at point P, this is one vector minus q, and this is another vector electric field for positive plus q. Now see, you have two vectors with you which are in opposite direction. You have to take out the resultant of electric field at this point. So see, the resultant of electric field at point P. So the net electric field, or let me write axial only, so that when we'll do the next case, you will be remembering that this is for axial. So see, E axial This will be if you use superposition principle also, or if you use your simple vector addition also, this will be E minus Q and E plus Q, the sum of these two charges. Now see, wherever we are writing E axial, the net sum of electric field at the axial point, this is the resultant what we are calculating. E plus Q and E minus Q. So let's take for E plus Q. Before that, let me tell you, whenever you are okay, we'll take the common in the last one. Let's write for each of them separately. All right, E plus Q. This will be K Q divided by I R minus A whole square. For E minus Q, see, I'll have to write this minus sign. Now we are not writing the vectors. We are actually solving the vectors. So this will be minus KQ divided by R plus A whole square. Is it clear till here? First tell me.
You can explain once more.
Okay. See, we have these two with us. Look, for the negative charge, electric field is going towards the left side, and for the positive charge, electric field is going towards the right hand side. So see, you have two vectors with you. This is point P. At this point, you have one vector E minus Q, and you have another vector that is E plus Q. This is clear to all of you, Atif? How
Yes,
have we
teacher.
written the direction? Okay. Now see, we have to find out the resultant electric field at this point. How the resultant will be given? We have seen superposition principle. If we are having more than a single charge, then how do we calculate the resultant phenomena like electric field or force? We just take out the vector quantities. So what do? We individually add them. Means if we have E plus Q with us, whatever will be E plus Q will get added by E minus Q. This is according to superposition principle. Yes or no? That's what we have seen in superposition principle. Whatever the resultant charge or whatever resultant electric field will be, this will be the sum of electric field due to individual charges but added vectorically. So we have to add them vectorically. Now see, both these electric fields are in opposite direction. So should we add them or subtract them if you take the magnitude?
If you subtract them.
We will subtract them. So see, this is E plus Q what we have calculated over here. This is E plus Q, KQ by R minus A. So I have just written K so that this gets simplified. We'll write 1 by 4 pi epsilon naught once again. Minus KQ divided by R plus A square. Both of these. Is this clear now? How have we written this?
Yes, teacher.
Okay, any doubts still here? You can ask me or you can write it even if you wish. Now see, from this, let us take K common, Q common. Both these quantities are common. So K and Q will be common. Let's see what are we left with. R minus A whole square minus 1 by R plus A whole square. We have taken KQ common because this was common in both of these, and for plus charge also and for minus charge also. This was common. Now see, we just have to substitute this. So for K, we can write Q divided by 4 pi epsilon naught. K I have just expanded, whatever is for K. Now see, if you remember it, for this charge, R minus A whole square, R plus A whole square. A minus B multiplied by A plus B. What is this? A minus B. Yes, Shavya? Shavya was saying. Yes. A square minus B square. So over here, you don't have only R minus A or R plus A. You have R minus A whole square multiplied by R plus A whole square. Yes. So see, it will be raised to 4 only. So see how will we solve this? Or we can do one thing. We can open the brackets also for solving them. Or you can do one thing. You can simply use the identity. Even if you use the identity, you have r minus a whole square with you. You don't only have r plus a whole square with you right now whenever you are calculating for it. So what you can do, you can expand this or take the LCM simply. Taking the LCM will be easier. Instead of writing this, let's take the LCM. So LCM will be product of this. So here this will be r plus a whole square. We have multiplied it with the numerator minus this term gets multiplied over here, r minus a whole square, and both these quantities get multiplied in the denominator, r minus a whole square multiplied by r plus a whole square. Now is it resembling to this identity? A minus a and a plus b. But just ignore the square. Apart from this square, we have this term with us.
Yes.
Is it clear? How have we taken the LCM? We have just taken lowest common multiple. This was your, take it as a single number, take it as another number. What you do whenever you have to take out the LCM? You just cross multiply both the two numbers and multiply it in the denominator. That's what we have written. Now see. Q by 4 pi epsilon naught, this was common, r plus a whole square. You can expand this identity. Which is this identity when you expand it? Anyone?
A plus b the whole square.
A plus b whole square, just expand me, tell me what will it be?
R
A
square
plus
plus
2ab plus b square.
2ir.
Yes, this is correct. R square plus a square plus 2ar. This is for your first bracket. For the second bracket you have, see, this will be r square. So r square with minus, this will become minus r square
Plus a square.
plus a square
Oh, minus a square.
minus a square. See, multiplied with this negative sign. We don't have a positive sign. So we have to just convert the sign. And since it is minus 2ar for this negative identity, so
Yeah.
minus 2ar with negative sign becomes plus 2ar divided by r minus a whole square. You can simply write it as r minus a, r square minus a square. C. This identity is what? A minus b into a plus b gives a square minus b square. So a square minus b square will be r square minus a square. Since we are having one more square, just square it, right, to the power 2. Tell me, is it clear till here? Any doubts till here, or you wish me to repeat from any step? Just tell me, because now it has been solved. Any one of you, if you want me to repeat, just let me know. Now see, r square will get subtracted, a square will get subtracted. Now see, what is left? We are left with only, now see, 2ar plus 2ar, this becomes
4ir.
4ar. So this is q divided by 4 pi epsilon naught. Here we have 4ar with us, divided by r square minus a square whole square. Now let us just segregate this 4a. We are having 4ar with us, no? So let's just segregate this as in q 2a multiplied with the 2, r divided by 4 pi epsilon naught r square minus a square whole square. What I've done, if I have 4a with me, can I write this 4a as 2a into 2? This 2a multiplied by 2 is still 4a only, no? So what I can do? I can just separate this. 2a into 2 will give me 4a only. So I can write this as 2a multiplied by 2. Now just look at this. Q multiplied by 2a. What is this?
Dipole moment.
Dipole. Yes, exactly. It is dipole moment. P is equal to 2a multiplied by this Q. So electric field at the axial line, this becomes 2, this 2, K for Sarah, you can stay. What you do after the class, you just watch previous lectures. Then I think what you can do, in this, we'll be solving the derivation, we'll be writing the derivation. So you will be having the formula. So you can solve whatever questions will come. Otherwise, you will miss today's class also and the next coming classes also. Okay, I'll explain you in short once again. Let me just explain this. I'll explain you once again. Then you will be able to understand much better. And watch the previous lectures from the first class and then come. Okay, Sarah?
Yes, ma'am.
Now see, this is 2 multiplied by k. K is 4 pi epsilon naught. This becomes the dipole moment P. This is R divided by R square minus A square to the power whole square. This is your dipole moment for axial line. If you are provided a point at the axis of any dipole, then the electric field is given by this formula. 2 K P R divided by R square minus A square to the power whole square. Is this clear?
Yes, ma'am.
Yes, teacher.
Okay. See, this is your derivation which comes in your examination. One is this, other one we'll do. But before that, how to solve these questions? This is the derivation, you will learn it. But on the axial line, how do we write out the direction? So on axial line, direction of field, this will be the same as that of dipole. Direction, whenever you have to calculate the electric field, and this case is given to you, the point is given you on the axis of the dipole. Then do one thing, check out whatever is the direction for dipole, and that direction will be the same for electric field on axial line only. So direction of field is same. This will be same as that of dipole. So on the axial line, whatever, like if I tell you this is minus q, this is plus q. Memuna, you tell me, what is the direction of dipole? Is it towards left or towards the right in this example? Yes, Memuna. Josefa? Direction of this dipole, minus q is there, plus q is there. Will it be towards the right, towards the left? Josefa, Memuna, you both have not responded. Hania? Okay, what is the direction, Hania? From which charge do you say? From which charge to which charge? Positive to negative or negative to positive?
Positive to negative.
Positive to negative. Or negative to positive. See, positive to negative, we don't take in physics. In physics, you have to take it from negative to positive. So, yes, Josefa, you were right, and Shavya, you were right. Hania, left it won't be left. See, when it was positive over here and negative over here, then we had this, whatever you give the answer. Now you have to see positive and negative, and from the negative, you have to go towards the positive. Negative to positive. Yes, Namuna, yeah, right. So this will be in this direction. This is P. This is the direction. Now, if I give you a point on this is the axis only of this dipole. So it means this is which case? Electric field on the axial line of the dipole. And for electric field on the axial line of the dipole, you have the direction of electric field same as that of dipole moment. So if the direction of dipole moment is towards right, Then for the direction of your electric field will also be directed towards right. This is how you take out the direction. So you have to remember the direction for the dipole moment. Now see, one more thing in this, before you write down and we begin the next case, you have to know one more thing. This is ideal dipole approximation. This is commonly used in your answers. Approximation. See, ideal dipole approximation means the size of the dipole is very small. So it means the R that we have taken, this is very, very greater than A. This becomes very, very greater than A. See, in this was your R. So R, if this is very small, means 2A is very small. 2A is small means A becomes smaller. If A is smaller, then R becomes what? R becomes greater, much greater as compared to A. This is what is known as ideal dipole approximation. So under ideal dipole approximation, you have R greater than A. R is the separation from the center of the dipole to that point taken on the axial line. A is the half of the separation between the two charges. So R becomes greater than A. It means what we have written, R square minus A square. This can almost be written as R square only. See, if you have R square, which is a bigger number itself, and you're just subtracting a very smaller number. If you have 10,000 with you and you're subtracting 1 from it, so will you be writing 9999 point something, or you can approximately write it as 1000 again? You can simply write it as 1000 again. So what you can do, if you have a bigger number and you're subtracting a very smaller number, so that won't make a difference. That will be approximately equal to that bigger number only, because the subtraction of the smaller A now means when you are taking the ideal dipole approximation. So what you do, R square minus A square will be equal to R square only. You can think it like this. If you have 1000 with you, you are subtracting 1 from it. When you are subtracting 1000 from 1, this will give you 999. So 999 is almost equal to 1000. So you can write 1000 minus 1 approximately equal to 1000 only. No, not being very precise, you are approximating it. This can be written as this only. So what happens in our formula also, if you are given this case, whenever you are provided with the value of R, you are provided with the value of A also. Then you have to check between these. If you see R is so much greater than A, then apply this ideal dipole approximation. Otherwise, if nothing is given and you say that R and small a, both of these are comparable to each other, then you can do the simply formula that we have derived right now. So see, electric field was given by 2 kpr divided by R square minus A square whole square. We can write this R square minus A square as R square only. So this becomes 2 kpr divided by, instead of R square minus A square, I can write R square. I have just substituted this as R square. This whole square will be over here. So see, electric field will be given by 2 kpr divided by R to the power 4. This R will cancel one of its R, and electric field will be given as 2 kp divided by R cube. Is this clear? This formula is often used because many a times you are provided with such a value that the separation between the point and this middle point of the dipole is so much larger. It is much larger as compared to the separation between these two charges. So in that case, you can simply use 2 kp by R cube. For K, you can write it as 2p divided by 4 by 3 epsilon naught R. So in this, see how does electric field is now varying. Initially, electric field was given by kq by R square. Electric field varied as 1 by R square, inversely proportional to square of distance. Now observe in this, electric field is inversely proportional to the cube of the separation between the two charges. Is this clear? ideal dipole approximation, and when you have to use it. Direction will be the same. Direction, the way we have seen, for it will be same for the point on axial line. Is this much clear? This section clear?
Yes, ma'am.
If any doubts are there, doubts are welcomed. You can write me in the chat box, or you can unmute yourself. Just start noting it down. Wherever you get stuck, ask me whichever point is not clear. Or if you wish, I can repeat it also once. Sarah, what you can do, you can note them at least, so that when you will go from the first lecture, you will be able to understand it. This is, we are done with electric field, and we are done with electric dipole, and we are just finding out the relation between these two. So derivations might be very long for you, but at least you should have the notes with you, so that when you will see once again, you will have all the notes, and it will be able to you will be able to recognize it better. All right. And for the next class, you can keep on watching the classes, previous classes. Yes, Mamona, this relation is correct between the relationship between E axial and E equatorial. We'll also see right now also. We'll check this. How is it coming twice? Just text me once when you are done. Fine. Now see, this was electric field at the axial point. You have one more case with you, that is electric field at the equatorial point. Electric field on equatorial line of the dipole. Now see, axial line, under axial line, we had the line that was on the axis. Whatever is the axis of the dipole, wherever the point will lie on this axis, we will say the point is lying on the axial line of this dipole. Regarding the electric equatorial point means on the dipole, if you take a perpendicular point on the perpendicular of it, like if I give you this point minus q, if I give you this point minus q and we have plus q with us. Let's say the separation again between these 2 points, this is A, this is A. So the total separation between both these two charges, this becomes 2A. So this again is forming a set of dipole to you. If I take a point over this side, means at a point on the bisector of it. If I take a point on the perpendicular bisector of it, that gives electric field due to the dipole on equatorial line. Now, in case of axial line, we had the point within this axis. If your point is here, or is between these two. Regarding equatorial point is considered whenever you have the separation. You can take the separation as R now, the R that was previously given. So this now becomes R, this is minus Q, this is plus Q, this is your dipole separated by this separation 2A. Now this is another point, we have taken point P. Now we have to calculate electric field at this point. So this is on the perpendicular line of this dipole. So this becomes your equatorial line of dipole. So you have to identify whenever you are given a point. So you have to identify whether it is lying on the equatorial line or on the axial line. If it is lying on the axial line, means in this axis, then you have to use the formula that we have discussed in the previous case. Or if it is given on the perpendicular point like this, then we use the equatorial line of dipole. Now see, you have to take out electric field at this point. So see, because of negative charge, let me just join these two. Now see, electric field because of the negative charge. So yes, Shravya, you tell me. For a negative charge, what is the direction of electric field? Is it towards the charge or away from the charge?
For negative, it is towards the charge.
Towards the charge. So since this is a negative atom that we have, negative charge that we have, the direction will be towards this charge. This is electric field due to minus Q. For positive charge, we have opposite to that of negative, means electric field is away from the charge. So this becomes, see, this direction will give towards this point, away will give us this point. So this is electric field due to this positive charge. Now see, whatever will be the resultant, what we have to do? We have to resolve these vectors. Because we cannot solve these two vectors directly in these plane, what we have to do, we will have to resolve these two vectors. So resolution of vectors, if I say this is theta and this is theta, now we have to resolve some vectors. So if this is E plus Q, let's see all of you who have remembered resolution of vectors. Yes, Sarah, at least you can tell me if this is E vector, this is making an angle theta, then what will be this? If this is E, it is making an angle theta, then what should I write this as? Not parallelogram law, Shravya, you have to simply resolve these two vectors. If you are given an angle, then how do you solve the vectors? Yes, Memuna. If this is E plus Q, this is theta given, then this will be?
E plus Q cos theta.
Correct. This will be E plus Q. E plus Q as in E plus Q, this will be cos theta. And the perpendicular line, this will be E plus Q sine theta. This is how you resolve a vector. See, resolution of vector includes whatever is the theta making an angle with the axis. That is taken as cos, and the opposite one, means the perpendicular one, that is taken as sine. So theta was given with this axis. So this becomes E cos theta and this becomes E sine theta. Similarly for E minus Q, theta is making an angle with this axis. Here we don't have theta, we are having theta over here. So this will be E minus Q cos theta. Similarly, perpendicular to it, this will be E minus Q sine theta. For all those who have forgotten this, let me just revise it again. See, if this is your vector A, this is a vector A, it is making an angle theta. Then what you do, the angle with which, the line with which this is making an angle, means this axis. Let's say this is X axis, this is Y axis. A is making an angle theta with X axis. So A becomes, this becomes A cos theta. And whatever is left, means the perpendicular one with the axis with which the A or the vector is not making any angle, this becomes sine theta. So this is A sine theta. That's how you resolve a vector whenever you are given. Similarly, we had E plus Q and E minus Q. In order to solve these two, we required this resolution of vectors. See, Shravya, we couldn't use parallelogram law because we are not aware of this angle between them. Even if you take 2 theta, how will you solve it? You don't have any value. In the example that we have done where we have used parallelogram law, there we had the equilateral triangle. So for that, this became 60 degree and ultimately we were left with 120 degree. But here you are not provided with any equilateral triangle. Only random triangle is given. All right. Okay. So that's why we have used resolution of vectors. So this becomes sine theta and these are cos theta. Any doubts in the resolution of vectors?
Notice.
Okay, one more thing also, we have to find out the separation between the charge and the point also, because that is also required. See, when we did axial line, we also took the separation between the point and the charge. So see, we have to take out this separation as well. Now look at it, how will we take out the separation? See, this is R, this is A, only this. If I name it as A, P, B, then in the triangle, or let's say this point is O, O, P, B, this part. If you have R with you, if you have small a with you, we will be able to calculate this using simple Pythagoras theorem. This will be r square plus a square. So now the separation between the charges that we were taking earlier as r minus a and r plus a, here it becomes under root r square plus a square. So separation between the charges regarding this point, is this clear? How have we calculated this r square minus a square? R square plus a square?
Yes, ma'am.
Okay. Now see, electric field, if you take out the magnitude of electric field, so electric field for the negative charge or the positive charge, electric field for negative charge just becomes kq divided by the separation between the charges. So this will be r square plus a square whole square. That's how we write, no? Kq divided by r square. Instead of r square, we have the separation between the point and the charge as under root r square minus a square. So this becomes whole square of it. So you can write it as kq divided by r square plus a square. Similarly, for the positive charge also, the magnitude will remain same, kq divided by r plus a whole square. Now see, how will we solve this? This is the magnitude that we have. Now we just have to put it in the values. But where do we have to find the values? See, all the positive charges of sine theta means E plus sine theta that are above the axis, and all the negative values E minus Q, these are below the axis. So won't they get cancelled? What will be the net electric field along y-axis? Just look at the y-axis. Even if you take n number of electric field, after resolving, all the sine theta will be for the positive, it will be above the axis and it will be below the axis for sine theta. Now see, if you see the net field, so what will be the net field along y-axis? See, Ey will be E whatever plus sine theta minus E minus sine theta. So whatever is going above the axis, this is coming below the axis as well. So this will be simply equal to 0. That will get cancelled. E plus sine theta is there, and see, magnitude of E sine theta you have seen. For plus also it is this and minus also it is this. Sine theta is also same. So E plus and for E minus sine theta, all the signs have got cancelled. Is this clear? Net field along y-axis.
For x-axis it gets added up. For cos theta.
X-axis it will get added up because both of them are in the same direction.
Yes, ma'am.
Since both of them are in the same direction, net field along x-axis if you calculate. For y it will be 0 because this will get cancelled. So net field along x-axis if you take, this will be now E plus cos theta. This will get added up with E minus cos theta. E minus cos theta means electric field due to the negative charge that we have. So see, since the magnitude is same, you can simply say 2E cos theta. Now we don't need to separate plus and minus because we have seen the magnitude is same. KQ divided by R square plus A square we are getting. So net electric field along x-axis, this will be 2E cos theta only. Now see, let us put the values. For electric field, this is 2. Instead of E, you can write KQ divided by R square plus A square with cos theta. See, how have we written electric field? We have written electric field from here. KQ divided by R square plus A square. Is this clear? How have we written? Now we have to substitute cos theta. So see, cos theta in this triangle you have to take A, P, O. Just consider this triangle. This is point A. This is point P. And this is point O. This triangle I'm talking about. A, O, P. Now in this is theta. This will also be theta. Now tell me what will be cos theta in this triangle. This is R square plus A square under root. This is A, this is R. What will be cos theta? Any one of you can tell.
A by root of r square plus b square.
A square. See, how do we write cos theta?
Adjacent by hypotenuse.
Yes, it is given by whatever is the base divided by the hypotenuse. So if this is your theta, you can write the base as, you can directly even write it down. If you take the base, this is your base, this is A. Now see, this was theta. So your theta will be this. This becomes your theta. See how this is your theta. This angle was theta. We cannot take this angle as theta because we are not aware that this is bisecting it. So we have to take it as theta only. Otherwise, this will be on the assumption that this was 45 and this was 45. So we should not take it as theta. We have to take this as theta. Why? Because you can see alternate angles. This is theta. So this will also be theta. Is this clear how this is theta? These are two parallel lines with a transverse between them. So these become alternate angles. This is your theta. So base is A, hypotenuse is under root r square plus A square. This is your cos theta. Is it clear till here?
Yes, ma'am.
Alright. Now we have to substitute cos theta's value what we have calculated. So this is 2kq. Cos theta is, this is A divided by, this was r square plus A square under root, and this was r square plus A whole square. Now see, 2aq, this again becomes your dipole. So here we have this part. This is what? 2aq. This is your forming your dipole only. So this becomes kp divided by, if you write it as, if you add them, r square plus A square, this will be to the power 3 by 2. See how this is r square plus A square to the power 1. And this is r square plus A square to the power half. So half plus 1, this will give you r square plus A square to the power 3 by 2. So you can write electric field as Kp divided by r square plus A square to the power 3 by 2. So this is what your net electric field line is given as. Since y is 0, this will be the net electric field on the equatorial line. Is it clear? Let me repeat for equatorial line in brief. See, we have taken this point. This is your point that we have to calculate. For negative charge, it will be towards the charge. For positive, it will be away. We have resolved the vectors. What we have concluded? All the signs are getting cancelled. So net electric field along y-axis is 0. What is left? All the net electric field is directed in one direction. This means all the cos thetas get added up. Now see, we have seen the magnitude of this kq divided by r square plus A square. How have we written it? Because the separation between the point and the charge is under root r square by A square using Pythagoras theorem. Now see, net field along x-axis, this gives you e cos theta with addition of the another e cos theta. 2e cos theta you have. Now you just have to substitute the value of cos theta and electric field. Electric field we have seen kq by r square plus A square. For cos theta, what you can do in this triangle, since this angle is theta, of using alternate triangle, because these two lines are parallel with this a transverse between them, this angle also becomes theta. So if I separately draw the triangle, this is the triangle with A as base and under root r square plus A square as hypotenuse. So cos theta is the ratio of base by hypotenuse. This will give by A divided by under root r square plus A square. Once we have substituted the value, we are left with, we have taken 2qa as p, which is the dipole moment. So equatorial line, for equatorial line, this is coming as kp divided by r square plus A square to the power 3 by 2. To the power 3 by 2, how? Because this is to the power 1 and this is to the power half. When you will solve this will be to the power 3 by 2, 1 plus half. Is this clear now to all of you? Any doubts? Any part that you want me to repeat? Atif, Hania, Clear to all of you? Huzaifa, Maimuna?
Yes.
All right. So just note it down. If you are stuck at any point, just let me know. I'll repeat it once more. Okay, Shravya, you can leave. This is the last topic. We'll continue on Wednesday.
Thank you, ma'am.
Yes, Maimuna.
Thank you, teacher.
Yeah, Atif, sure. All those who have written, you can leave. This is. We will continue the next. I'll just come and revise this topic.
Okay, teacher. Thank you, teacher.
No. Sarah, Huzaifa, Hania, if you are done, just let me know. This is the last topic for today.
Thank you.
No. Okay, Huzaifa, fine. All right.